Again, it's a no-code Citrine platform. It's based on the cloud, and you use the web browser to interact with it. And it's comprised of 4 modules as a way of trying to holistically enable this workflow of iterative sequential learning that Joel described in his part of the webinar. So the first module is a data module to interact with materials data, to upload it to the platform, to interact with it, to assess it in some basic statistical analyses like outlier detection and things like that. Then a module for building models based on that data. Again, it's a no-code model development platform, and I'll show you some of that in a minute here. But it captures the expertise of the materials and from science experience of the students. Maybe they've got something from their class work that they can throw in there in terms of material science information. I'll show you how we can do that, and that's part of the modules as well. Then once you have these models trained and ready to go, you develop a search space, basically defining the bounds of things like composition or manufacturing parameters within you, in which you want to try to find novel materials or optimum manufacturing processes. So things like composition, things like the temperature of your furnace, things like that can be used as define the definitions of the search space boundaries. And then within that search space, utilize the models to generate potential candidates. We use a Monte Carlo-based approach as a way of figuring out what are some the candidate materials or manufacturing processes that are going to be able to define or achieve the goals of the property targets that you set aside. Maybe I want to try to find something that's high strength or high corrosion resistance and low cost, which is what we're going to see here in a minute. And so this workflow is entirely no code. You utilize it through the platform. And then once these candidates are generated, ideally what would happen in an industrial environment is that a material science expert will look at the candidates, and because we have uncertainties of the predictions of whether, and not just the predictions themselves, we're able to identify what are the safest bets of these candidates, what materials, formulations, or manufacturing parameters are the most likely, most probable to achieve the target properties that we've defined. Or maybe you want to use this uncertainty as a way of saying, I want to take some riskier bets and I want to do something more exploratory in the laboratory. This is what this kind of information would be used to inform decisions about what experiments to run. Then the worker or the student will take that experiment to the lab, actually perform it, and then take those results of those experiments and feed that back into your data, and then you repeat this process. And this is the sequential learning loop kind of captured and enabled by the Citrine platform.